Alright guys, we're back. This time we'll be doing 9.2.4. This is actually a chemical reaction in an aqueous solution, or an aqueous solution, sorry. The question actually asks here, write the balanced net ionic equation for the combustion, or not combustion, sorry, the combination of iron nitrate and sodium carbonate, okay? Both of them are aqueous solutions, okay? Not combustion. Combination. Anyway, let's expand this a little bit, actually, because typically in order to find the net ionic equation, we need to find the molecular, the complete ionic, and then finally the net ionic. So I just want to do all three, just that way we understand exactly what's going on here. So the first thing you should know is that this is definitely, these are both actually ionic compounds. You know that because here's a polyatomic ion, right? We have NO3, and we should know from our polyatomic ions that this has a charge of -1, right? And we have two of those, so that's a total charge here of -2. And we have iron here. In this case, this particular type of iron will have, it will actually have a +2 charge. So more accurately speaking, actually, this is iron 2, okay? So this is iron 2 nitrate, not just iron nitrate, so that's a my bad. Likewise, you're going to see here's our polyatomic anion, okay? And here is our cation, okay? So these are both attracted to one another, both of them with a plus, either a +2 or a -2 charge. So let's take a look at this. So first we have our molecular equation, okay? So if we were to show this reaction, we're going to put in the original reactants here, because we're saying that it's a combination of these two here. So here we go. We have our iron 2 nitrate here, okay, and we have our sodium carbonate, okay. Both of them are still aqueous solutions. But then what do we put down on the product side? Well, typically this cation over here will switch over to the other anion, okay? And likewise, this cation will link with this anion. So what you see is that you see the iron has moved, right? It has moved from nitrate to carbonate. It is a fickle iron, okay? So now this is iron 2, keep in mind it's iron 2 carbonate, okay? So it switched the carbonate with the sodium. And the sodium here got the nitrate instead. So you can see it right here. The sodium is with the nitrate, and that's an aqueous solution. So this should be your complete molecular equation. You should basically be showing, you know, okay, well, we started with these two things, and then we switched cations, or we switched anions, depending on which way you look, and thus we have our iron 2 carbonate and our sodium nitrate, okay? Now, instead of making this like Na subscript 2, NO3, parentheses, subscript 2, I just put the 2 in front as a coefficient, because that should be the same, alright? You also have to make sure that this is a balanced equation, okay? This is especially important in the molecular, okay? Here I can tell it's balanced. Don't even worry about it, but in any other case, just make sure you're writing a balanced equation. So for the complete ionic, and this is always a pain, I always hate writing this one out, but for the complete ionic, you just want to break these down into their individual ions. So you're going to see your iron 2 plus, alright, so this is my iron 2, alright. Likewise, I'm going to have my 2 nitrates, as you can see over here. Now, I don't need to go through all of it, but the most important thing here is that you realize that, well, actually, in the complete ionic, you have to keep your precipitate complete, right? Actually, one thing I forgot to mention over here is that we have a solid precipitate left over here, and the reason why is because most carbonates, okay, over here, with some exceptions, alright, most carbonates will actually turn into a precipitate. Keep in mind, if you're not a part of the solution, you are a part of a precipitate, or you are, whatever. Anyway, so what I'm showing here is that even though we've separated all of these into their constituent ions, what we're actually going to see here is a precipitate, right? I don't need to break this down. The precipitate stays as it is. So, but everything else gets broken down into their respective ions, okay? So in the complete ionic, you want to make sure that you keep the precipitate or any kind of product, whether it be water or gas, anything like that, anything that, you know, basically results in the combination of these in a way that would basically stay cohesive. I don't really know the best way to put it, but you want to basically keep that as one unit in the product side, okay? So that's our complete ionic. Now we need to get our net ionic. So in order to get our net ionic, we're going to cancel out what we call spectator ions. So spectator ions are basically ions that appear in both the product and the reactant side. okay? AKA, they basically stay exactly as they are, alright? So here we have our two nitrates. Those are gone from both sides over here, alright? Here we have our two sodiums. That's going to be gone, alright? And what we're going to be left with, alright, we're going to carry down, and this over here will be our net ionic equation, okay? So keep in mind, all of these spectator ions are the particular ions that exist on both the product and the reactant side, okay? So we cancel them out, and whatever's left is the net ionic.